In this short presentation, I'm going to be summarizing what we experienced last week when I asked you to evaluate the quality of a short text which had been translated in 3 different ways. But then I'm going to be concentrating on what are called automatic metrics, in other words, ways in which you can evaluate the quality of MT output by using a computer-based methodology to do so. I'm not going to go through this list, but I just wanted to show you the wide range of approaches that can be used to evaluate MT. And most or all of these involve human agency. This, of course, is the one that we were using last week, user evaluation, when you were evaluating in pairs, and then we put together all the evaluations and we got a combined score. And as a matter of fact, I did that 3 times last week with 3 separate groups, and it may be of interest to you to know that on each occasion the evaluations that were assigned to each of the 3 translations were very close to each other. So with human evaluation, some of the advantages would be that humans possess wide range of different kinds of linguistic expertise. They know not only what's right and what's wrong linguistically, but they have views as to what sounds good and what sounds less good. Also, humans possess considerable amounts of world knowledge, so even if a sentence is grammatically correct, but it doesn't make sense because it's not referring to anything or not referring to something in a proper way, maybe talking about a person using the wrong gender, that would be an example, or referring to a city but not knowing that it's a city and thus referring to it in a different way. That kind of thing will also, an ability to understand that kind of thing will also distinguish a human user. And of course each human will have a very subtle understanding of what it means to be a translation of very high quality, and they will weigh a range of different things, such as the accuracy and such as the readability that we were looking at specifically last week, and they will weigh these up against each other and come up with an overall evaluation. Now the downside of all this is that each evaluator cannot escape being subjective, at least to some extent. They can't escape that entirely, and we did see that individual raters' scores last week did vary to some extent for each sentence. Also, if this is being done in the real world, then paying for people's time to do that costs a lot of money. So we took about 15 minutes to do that evaluation, but there were about 20 of you in each group. So if you multiply 15 by 20, you get 300 minutes, which is in fact 5 hours of payable time, and that was just to evaluate 2 sentences translated 3 different ways, in other words 6 sentences, some of which were very similar to each other, so it is quite pricey. So what's the alternative? The alternative is the use of automatic measures, sometimes also referred to as metrics. Now, to quote from Kancheda and her colleagues, a good automatic measure should above all correlate well with the quality of a translation as it is perceived by human readers. Okay, so it should be able to tell that a piece of machine translation output is of similar type to a translation that may have been produced by a human. Most or all of these measures are based on the assumption that the closer a piece of MT output is to a genuine piece of human translation, a professional human translation, the better it is likely to be. It also recognizes the fact that in spite of the fact that there are many different ways of translating a text or even a single sentence, a lot of those ways are likely to have a number of words and phrases in common. Now, to get a little bit technical for a minute, there are two basic approaches to the creation of an automatic metric, and they are the Levenshtein-based and the n-gram-based. We're going to look at the n-gram-based. These are commoner, and the one that we're going to be focusing on specifically is of that type. So an n-gram, this is a term used quite a lot in something called, an area called computational linguistics. We will be talking about n-grams on and off over the course of the semester. An n-gram is a sequence of n words. So you can have 1 grams or unigrams, bigrams, or 2 grams, trigrams, or 3 grams, and so on. And the best known metric which uses the n-gram based approach is the BLEU score, which was developed by IBM. Now, BLEU stands for Bilingual Evaluation Understudy. You don't particularly need to remember that. It's quite an awkward phrase, in fact, but remember it as the BLEU score. And the way the BLEU score works is that it relies on comparing an MT version of a text or a set of sentences with either a single human translated version or sometimes a number of alternative human translated ones. And it looks for similarity between n-grams. So first of all between single words in the MT output and one or other of the human translated versions, and then it looks for bigrams in common, trigrams, and so on. So to have to look at an example, this is actually a very poor machine translated version of the text in the top left hand corner, and as you see there is in fact very little in common between the two of them. And the score, the BLEU score, which is assigned, it will be somewhere between 0 and 1, 1 being 100%. And that reflects the percentage of machine translated n-grams which can be found in the reference translation or one of the reference translations. Now, it's important to bear in mind that you're not allowed to use the same portion of reference translation twice. This is to stop cheating. And you can't include, for example, you can't include the sentence the as a reference sentence and sort of tick off each the that's used. In general terms, it's very difficult to cheat, to find a way to cheat so that you get a better BLEU score than is justified by the quality of the text. Here's another example. This time it's the same MT version. This time it's being compared with not one but 4 different human translations, and here you do see that there is more in common. Certainly as a proportion of the machine translated text, but there are relatively few words which are matched in each of the different human translated texts. Okay. So once again, to get a bit technical, the BLEU score relies on something called the clipped n-gram precision, and this is defined as the fraction of n-grams in a set of translated sentences that can be found in the respective references. It also employs what's called a brevity penalty that penalizes producing short sentences containing only highly reliable portions of the translation. In closing, the BLEU score is not the only automatic metric that uses the n-gram based methodology. There are others, some of which are quite known. They include, for example, NIST, Rouge, Blanc and Meteor. Okay, thank you very much.